Hello, Internet. Let's have some fun for some minutes together. Let's talk about our large language model, about GPT-3, I told you, and let's explore it yourself. So we have here on Hugging Face GPT Neo 2.7 billion. It's a transformer model designed using the replication of the GPT-3 architecture. It has 2.7 billion parameters. It was trained on the Pile. I had a video on the Pile, the 800 gigabyte file in a specific video. And it was trained for 420 billion tokens over 400,000 steps. This is okay, this is nice, but let's play around a little bit with it. And I put here in a text generation exercise, they host an inference API, the nice people from Hugging Face. I put in the highest mountain on Mars is, and you know, it is Olympus Mons. But what will the compute come up with? The highest mountain on Mars is named Norfar. It's named after the old English goddess of Earth. It's a rocky peak, the height of 12 kilometers above sea level. No, I mean, 12 kilometers is not bad, but I think Olympus Mons is about 22 kilometers high, if I'm correct. So you see, the highest mountain is now. Let's compute another time. Let's see what the system comes up now. The high, oops, that's a little bit strange. On Mars is a volcano. Yes, there are two questions I always think when it comes to space. Okay, the first, what is the highest on Mars? Oh no, simply, this makes no sense at all. This makes no sense at all. Let's compute it again. The highest mountain on Mars is? The highest mountain on Mars is called Neptunus B, and it is thought to be the highest on Mars. That is because the geological record does not provide evidence for a higher mountain. Now, it sounds logic, no? I don't know what is a Neptunus B. Well, you know, let's have some fun. Neptunus B. What the hell is Neptunus B? Neptunus B is baseball. Seafood? No. Neptunus B, and let's say Mars. Neptunus, yeah, Neptunus B. Oh, well, Neptunus. Which language are we? I don't know. Neptunus B, Mars, over you, Neptune, yeah. Okay, so you never know what the system comes up with, but no. But you know what? Let's make it an easy one. Meaning of my life is. Now, let's compute this. This is one of the most intelligent AI systems in the world. The meaning of my life is something. The meaning of my life is something. That's a little bit disappointing, I would say, but okay, it is something. I've been meaning to write down where my life is going and where I was in a little more regularly. I usually find this meaning is right around the corner. but you can guess where this comes from, yeah? Let's compute it another time. The meaning of my life is, now it took 2.5 seconds, is like how I came to speak English. The first time somebody told me to get a job or a degree or a passport. Second time I went to Thailand, worked in a small shop. No, nobody told me to get a degree or passport or work in a small shop in Thailand. So you see, this is the beauty of an LLM. You never know what comes out. But hey, we want to learn something today in this video. We're already 4 minutes in, and now comes the part where we want to learn something about this model, and we have a look at the files. And the good people at Hugging Face provide you with the specific files for the specific model. And what I want to show you today is the tokenizer, your input data. Yes, I know, it is important that you get the corpus of your text, the corpus of your sentence for your input data for the data pipeline to your BERT model, to your transformer model, to NLP, whatever. But you know, to get the right architecture for the tokenizer and to get the right vocabulary is of most importance. So therefore, you can tune your AI model, your deep learning configuration, whatever, if the first step, the input data representation, the breakdown of the sentences in words, in subwords, in characters, which define your specific vocabulary for your specific piece of text, for your specific task. And then you choose a tokenizer. And you will see the tokenizer is really important because the transformation of whatever the text is broken down into are numerical values, so that you have either some vector or you have some tensor, and the matrix multiplication or the tensor algebra can go on within your BERT model. So therefore, this transformation at the very first beginning, when you have your input data, you have chosen a data set as the data set that you train your model on. But the representation of the sentences in this model, the mapping to a numerical value set, you can also modify this. You can have for your specific task, for your specific data set, an optimal representation. And this is the topic of this video. So just to show you, whenever you have those huge models, you have a vocabulary. And this vocabulary is normally in JSON. And when you run through this vocabulary, you will see, okay, it takes a little bit of time. Yeah, here you can see it was trained on the pile. This is what we had. Here we go. That's the word. We have here the word after. And the word after is encoded as numerical value 706. And, well, how? The word how. Don't care about the G dot. These are just some special tokens. The word how has the code 703. And if we go on a little bit down the vocabulary, you will see, gee, this takes time, that we have the word, here we have the word future. Don't care about the special token G dot. Future has the numerical encoding 10,898. And then you have burn. And there's no special token, so you see, hey, this could be really a word, 10,899. And so it goes on. So what we learn, which word are part of your vocabulary is important, and how many words, what is the size of your vocabulary is of importance. Because, you know, sometimes you have a vocabulary typically of 20,000, 30,000 words, or tokens, and now you have here, for example, 50,000. So LLMs, the bigger they get, the more they can really get into the details and find words. But let's say, for example, bacon has the numerical encoding 28548. So this is great. And whatever files we have, the configuration, yeah, I think this should be very small. Just tell us we have our special token, end of text, then a prefix, the model length is 2K, special token, map file, null, name, or path is based on a GPT-2 model. This is it. If we go back to our models that are provided here. So what I would recommend for you to do, go to Hugging Face, play a little bit around, choose, I don't know, a fill mask task where you have a mask over one word of a sentence and have a look what the system comes up with if you choose different models, a small BERT model, a big Roberta model, a GPT-2 model. Have a look, play around with this. Have a look at question and answering tasks. If you have a question, what the system comes up with. Of course, similar is summarization. You put in a paragraph of text and the system makes a short summary, 1 or 2 sentence summary. You can have text classification, you can have token classification. This might be of interest for you if, let's say, you focus on the English language and you have a BERT-based named entity recognition task. There is a model for you updated September 5, 2021. So there are so many gorgeous models to explore on the platform of Hugging Face. And if you go to your model page, there is some beautiful models waiting for you. You can have a look at translation, whatever language you want to translate to or from. You have sentence similarity as BERT applications, sentence BERT models applied. And we had at first a look at text generation. So play around with it, have a look at it. And the next step we are going to take in the next video is we download from the libraries a TensorFlow specific code. You also can go with PyTorch or JAX. I also had a video on JAX on YouTube. We choose in English. I choose English just to be on the safe side for everybody. And then you have data sets that you can specifically select. If you want to have the data set that the transformer has been trained on, it has to be Wikipedia. You can choose it and then you say, okay, apply my filters. And here you have an XLNet based case, for example, for text generation. And have a look at it, play around with it a little bit, get familiar what different models can do. And the next video will be, we will have a deep dive, we will code ourselves some model. When, of course, we start with the input data set, and we will have a look not at the transformer model itself, but at the tokenizer. The tokenizer itself, if you have some input data, how to transform your written English input data into a numerical presentation that is optimal, an optimal representation for the specific model you choose, your deep learning model you choose for an LLP task. This is it for today, and I see you in the next video.